This is problem 5 from chapter 3, worksheet number 3. It says the table below shows the data over time for the amount of money in an account. So you see we have time in years and we have the amount in dollars. Our time in years seems to be growing by 2 years each time here, right? So it's going from 0 to 2, 2 to 4, 4 to 6, and so on. And it looks like the amount of dollars we have here is decreasing. It's going from $18,000 to 6,000, 6,000 to 2,000 there. So letter A asks us, assuming no money is being deposited, write an exponential function that models the data. With this one here, we can already see here that we've got our starting value up here, right? We've got basically when our x is 0, we have $18,000 there. So if we're trying to write an exponential function in the form y is equal to a times b to the power of x, okay, what we see there right now is that our a is going to be 18,000. But we still need to figure out what b is going to be. And because these are changing by 2 each time there, we have to be careful, right? So what we're going to do here then is we're going to use this information that a is 18,000, and then we're going to choose a point. We can just choose this point right here, the point that would be 2, 6,000, right? We'll treat that like it's an x, y, and we're going to use that along with our a is equaling $18,000, and we're going to plug it into that equation to solve for b. So here we go. We've got 6,000 is equal to our 18,000 times b to the second power. So we'll just go ahead and solve this. We're going to divide each side by 18,000. So 6,000 divided by 18,000 is going to be 1/3. Right now that equals b squared. So when we take the square root of each side, we get right now that b is equal to the square root of 1/3. Now that we know a and b, if we want to write out our equation, it would be y is equal to 18,000 times the square root of 1/3 raised to the power of x. Or if we're treating it like it's a cost function here, you may see it as like with a of t is equal to 18,000 times the square root of 1/3 raised to the power of t. So you may see it like that as well. However, when we look at that there, that's kind of a messy looking, go away. It's kind of a messy looking multiplier there. So let's see if we can rewrite that multiplier and kind of clean it up a little bit here. If we think about it, the square root of 1/3 there, we could rewrite that as 1/3 raised to the 1/2 power, right? Something to the 1/2 power is the same thing as taking the square root. And since we're taking those and we're raising them to the power of x or the power of t, right? If I raise this to the power of t, we can now apply our property of exponents where we're raising a power to a power, and we can rewrite this as, see, I ran out of room there, I'll write it up here. We could rewrite this as 1/3 raised to the power of t divided by 2. Right, and then we could throw that down in here. So that would just change what our equation looks like a little bit. That would say here, we'd say a of t is going to equal 18,000 times 1/3 raised to the power of t divided by 2. So those are equivalent, functions. They mean the same thing there, just, one has a little bit cleaner looking multiplier than the other one. So the second question here in number 5 says, how much money will be in the account after 1 year? So this should help us since we can't look at the table and get that answer, right? Because 1 year isn't on there. We're going to take it and we're going to plug in 1 for our t, because t is representing the number of years. So we're going to say here, a of 1 is going to equal 18,000 times 1/3, and then when we put in that 1 in for t, it looks like we're just raising it to the 1/2 power. So you can take that there and you can use your calculator to compute what that would be. So we'll say 18,000 and we'll get, in the end, $10,392, and it looks like 30 cents. So that would be how much money was in the account there after 1 year. All right, that is the answers to number 5. If you have additional questions, please make sure you ask in class. Otherwise, thanks for watching.